Good morning, one and all. In today's lecture, we will see the next numerical on the multi-stage gearbox. Okay, I will read the statement. Say, in the multi-speed gearbox is to be designed for a small size. This is the general purpose of machine tool gearbox. You have given the spindle speed is minimum spindle speed is given 56 rpm, maximum spindle speed is given 1000 rpm, and they are using for the application of this is the small size of gearbox for the general purpose of machine. They have given the series R4 series. Okay, means indirectly they have given the 5 value, geometric progression ratio value is given, and the electric motor speed is given 720 rpm, and we want to find out or select the optimum structure diagram. Here we will use the new thing is a we will use the node method. Okay, in this lecture I will tell you how to find out the feasible solution with the help of optimum node method, using the node method. Okay, then let's see first. The what is the first point? We want to they have given the phi value. Phi is nothing but the geometric progression ratio. Okay, this value is phi is equal to this R4 series is given. Already previous lecture I have explained what is this and how to calculate. You have to write 4 root of 10. 4 root of 10. If you have calculated this, then you will get the 1.78. 1.78. You will get the geometric progression ratio. Suppose you have given the R8 series, then you should write here 8 root of 10. Then you will get this related value for the R8 series. All of you getting? Then next is a range ratio. How to calculate the range ratio? It is the ratio of maximum spindle speed to the minimum spindle speed. Okay, both values are given. 1000 divided by 56 is there. If you have calculated, then you will get 17.857. Okay, you will get the range ratio. How to calculate? It is the ratio of n max to the n minimum. Then next, third, we want to calculate the total number of speed steps. Okay, they are not given the speed steps in between n minimum and n max. Then how to calculate that total number of speed steps? Using the formula already we have seen, log 10 Rn into phi divided by log 10 pi. Log 10 pi. Use this formula and find out the value. We know that Z is equal to what? Z is equal to, we want to calculate log 10 as it is. What is the value of Rn? Rn is 17.857 into what is the value of phi? Phi is 1.78 divided by log 10 1.78. Okay, you will give this value is 6. Means number of speed steps. We have got the number of speed steps, 6 number of speed steps. Once you have got the number of speed steps, then we want to calculate the particular spindle speed. Okay, next step is a spindle speed. Okay, this is denoted by the NK. First we want to make the table speed steps, then spindle speed. I will write the expression, or we can say the equation for the spindle speed, and here I will write the speeds. Okay, then how many steps are there? 1, 2, 3, 4, 5 and 6 steps are there. Okay, therefore that we can calculate. First you know the how to calculate the n1. N1 is nothing but the n minimum. How to calculate the n2? Yesterday we have seen n1 pi. N3 is equal to n1 pi square. N4 is equal to n1 pi cube. and n5 is equal to n1 5 raised to 4 and n6 is equal to n1 5 raised to 5. Okay, use this formula, put the value. We know the n minimum is a 56. Then you will get the different speeds. n1 is equal to check. This is minimum, and finally you will get the n6 is equal to 1000. We want to achieve the maximum spindle speed. n6 is a 1000. Then if you have calculated, then n2 you will get the 100. Then you will get the n3 is equal to 177. n4 if you have calculated, n4 is equal to n1 5 raised to cube, you will get the 315, and last n5 you will get the 560 is there. This all value you will get in the RPM, revolution per minute. Okay, all of you getting how to calculate the spindle speeds, different spindle speeds. Once you have got the different spindle speed, then next step is that we want to calculate which value? Yes, anybody? Yes, correct. Number of stages. How to calculate the number of stages? Yes, anybody? We know that next is a fifth number is a number of stages. It is denoted by what? N, capital N. Okay, here we have calculated the number of number of speed steps with number of spindle speeds. Then we know that this n is equal to what is the formula? Log 10 z divided by log 10 p is there. Okay, we want to assume the value of p. Z already we have calculated. We have the value of z is 6. Right? I will put here assuming this two value p is either 2 or p is equal to 3. And if putting this two value, then check that you will get the integer number or not. Log 10 z is equal to 6 and log 10 p is equal to 2. Then what is the value? And n is equal to log 10 6 divided by log 10 3 is there. You will get the integer number or not. You have to check that. You will get the 2.58 is there. If you are putting the value of log 10 is equal to 2, and here you will get the 1.68. Both answer you will get in the decimal place. Then what to do? What to do? Next, you have to use the modify the equation number 5. What is this equation number 5? If these values are not getting in integer, we can't say the number of stages is 2.58 or number of stages is a 1.68. Okay, we require the integer number. Then how to modify this equation? We know that z is equal to p raised to n and p raised to n1 and n2 is there. P raised to n1 and n2 is there. First we want the satisfy the condition of the z. We know that z is equal to what? Z is equal to p1 P2 is there. P1, P2 is there. Right? Then what is the Z? Z is equal to, we have the value 6. 6 is equal to 2 into 3 is there. 2 into 3. If you have taken here 3 or here 2, then this condition is not satisfied. That's why you have to choose the value of P1 is 2 or 3 or P2 is 2 or 3. Okay. Then I will put here z is equal to 2, 3. What is the value of n1 and n2? If you want to satisfy the value of z, then n1 is equal to 1 and n2 is equal to 1. How? If you have written here 2, then check that 2 raised to 2, you will get the 4 into 3, 12. This condition is not satisfied. That's why I will write here z is equal, then I will write here n is equal to n1 plus n2 is there. n1 plus n2 is there. What is the value of n1 and n2? 1 plus 1 is there. N is equal to, you will get the 2. Number of stages we have found out with the help of that given equation. Okay, last numerical we have got the directly answer. But in this numerical we want to modify this equation, right? n is equal to log 10 z divided by log 10 p. How to modify that? Z is equal to p raised to n1, p raised to n2. What is the value of p1 and p2? 2 and 3 is there. 2 raised to 1, 3 raised to 1 is there. Okay. All of you getting how to calculate the number of stages if this value are decimal? Okay, not an integer. That's why for this design of the gearbox we have selected number of stages are 2 number of stages. Okay, with in the first stage 2 speed steps and the second stage 3 speed steps, right? Once you have calculated that number of stages, then we want to find out the value of x1 and x2. We want to write the formula z is equal to, next is a structural formula. You know the structural formula. Z is equal to what? P1 x1 P2 x2. Okay, what is the value of P1? 2 is there. 2x1 3x2. P2 is 3. Z is equal to, then how to calculate the x1 and x2? x1 is equal to, assume the 1, and x2 is equal to, p1 is there. p1 is equal to 2. p1 is equal to 2. Then you will get the z is equal to 2 1 3 2 3 2. Okay, we will check with the help of that table. Yesterday I have given one table, p combinations. Check that. P combination, then x combinations, p combination, then x combination, and here is the total combinations. How many combinations you will get? We'll check. Here is the p1 and p2. First p1 is equal to 2 and p2 is equal to 3. I will interchange the place of p1 and p2. p2 p1, then you will get the 3 and 2 is there. There are only 2 possible conditions in the p combination. But in the x combination we will check x1, x2. What is the value of x1? 1, 3 is there. x1 is equal to 1 and x2 is equal to 2. Again interchange the x2 and x1 place, then you will get the 2 1. But if you have interchanged the value of p2, then again you will get here x1 is equal to 1. When you are assuming x1 for this condition, second condition. For this condition we will get these 2 formulas, right? For this condition again we will get the x1 is equal to 1, and what is the x2? x2 is equal to p1. What is the value of p1? Here is the p2 means p1 is there. Okay, 3 value is there. You will get the second combination 1 3. Okay, means x1 x2. Here is a 1 and 3 is there, and here is a x2 x1 3 1. Means you will get the how many combinations? I will directly write. Check that. This to this one. Okay. Then tell me the z is equal to, what is the first combination? 2 1 and 3 2. This is the first combination. Then second one, z is equal to 2 2 3 1 is there. 3 1 is there. Similar way I will use this combination and this combination. Check that. Z is equal to 2 2 3 1. This one 2 1 and 3 3. 2 1 3 3. And second combination z is equal to 2 3 3 1. 2 3 3 1 is there. Okay, and with the help of that second formula again you will get the new 4 structural formula. I will write z is equal to, from this you will get this one and this one first. 3 1 2 2. 3 1 2 2. Okay, then next z is equal to 3 3 2 2 1. 3 2 2 1. Okay, then next with the help of this to this 1 3 is there. 3 3 1 2 3. 3 1 2 3. Then next 3 3 2 1. 3 3 2 1. Okay, this 8 combination we have for the this numerical. Then once you have got the 8 combination, then I have told use the different condition and check the which is the feasible conditions. Okay, first is a product of pk xk must be factor of z. First condition, product of pk xk must be factor of z, and this should be integer number. Then second, product of pk xk must be less than or equal to z. Then what is the third condition I have given? This x1 is less than x2. And fourth condition, you have to check the ij stage. Then check that will eliminate we'll choose some feasible condition. First one, check that first one, z is 6 divided by 2, you will get the integer. 6 divided by 6, you will get the integer number. 1 is less than 2. Okay, and product of this less than or equal to z, means both conditions are satisfied. Then third condition also satisfied. We will check the ij stage also. Okay, this formula is correct. Then I will check only with the help of x1 is less than x2. Okay, this is the correct one. Then this one, 2 is less than 1, wrong. Then this one, 3 into 3 9. Okay, means 6 divided by 9, you will get again decimal value. 3 is less than 1, this is again 1 is less than 2, 4 is there, 4 again decimal. 2 is less than 1, again wrong. 1 is less than 3, this one correct. Okay, 3 1 and 2 3, this is 3 is less than 1. Means out of that 8 formulae, you will get the 2 are feasible solution. Z is equal to 2 1 3 2, and last one z is equal to 3 1 2 3. Okay, we want to draw the for both structure diagram. Okay, I will draw here that for two structure diagram. No need to draw all the structure diagram and check all the ij stage. You have to only check which is the feasible solution. You should write here these two are the feasible solution. Okay, feasible solution. Then check that first how many vertical lines will draw. Yes, anybody? There are two stages, means n plus 1, 2 plus 1, 3 lines. Okay, and horizontal lines, there are number of speed steps 6, 1 2 3 4 5, and last is a 6. You have to take the appropriate distance and draw this. What is the structural formula? 2 1 3 2 is there, right? I will draw this 2 1. Okay, we will start from the center, then check the center 1 2 1 2. You will get in between 3 and 4. Okay, here is a first node point. Okay, this is the first shaft, input, intermediate, and output shaft, third shaft. Okay, 2 1 is there. 2 and 1, gap is 1. Okay, should be gap is 1. Okay, then 3 2. Here is a 3 line and gap should be 2. This is 3 line. If you are getting the 3 line from this point to, you have to draw the horizontal one, and then gap is a 2. Then this one. Okay, and 1 and 2 again gap is a 2. Okay, means total gap you will get the 4 gap. Right? Then from this point again, here you should draw this one 1 2 and 3. This is the first diagram. Then second one. Then similar way you should draw. Here is a 6 horizontal line. 1, 2, 3, 4, 5, and last one is a 6. And how many vertical lines? 3. Okay, 6 is there. Then we will start from again in between 3 and 4. What is the structural formula? 3, 1, 3, 1, 2, 3. 2, 3. Okay, 3, 1. Again here is a 3 transmission line and gap should be 1. Okay, 3 transmission line. First you have to draw the horizontally. Above that we require the gap is 1. Okay, means here, and half of this you will get the gap is 1. Okay, 3 transmission line, 3 means P means 3 transmission line. Should remember that, and gap is a 1. Equal gap is between the from the center. 2, 3. Here we require the 2 transmission line and gap is a 3. Gap is a 3 means 1.5 go this and below the 1.5 this one. You will get the total gap is a 3. Okay, from this again this to this and this one, this to this. This is the structure diagram. Okay, all of you getting how to draw the structure diagram. Then once you have drawn the structure diagram, then see we have got the two solutions. Then we want to find out any one. Okay, here all conditions are satisfied. Then how to use the or implement the optimums, how to find out the optimum structure diagram. Here you have to use the node method. Node method for the find out the optimum structure diagram. Okay, in the node method again you have to make the table. First feasible solution. In the first column you should write the feasible solution. Then next you have to write the node on transmission line. Node on transmission line. Transmission line. Then here is a how many shafts we are used? 3 shafts. 1, 2, and 3 shafts. Here is the summation of node. Okay, last column you should write the remark. You should write the remark. You should make this table in the node method. When you find out the feasible solution, you will get the number of solutions. Then you should make this table, use the node method and find out the feasible solution. Here I will do this is the diagram number 1 and this is the diagram number 2. Two structures. First one and second one. Okay, you will get the number of diagrams if the feasible solution are more. Then node on the transmission line. How to calculate the node on the transmission line? Check that first. Remember that you should take the maximum one. You should take the maximum one. Okay, which is the maximum one? I will check this one. Okay, this in between 3 to 4. First node is in between 3 to 4. Means you will get the 3.5 is there. Okay, then we are coming on the 4 on the second shaft. Where is this node? 4. Then third shaft, where is this node? 6 is there. Then you have to make the summation. You will get the 13.5. 13.5 is there, right? 13.5. Similar way you have to check the second one. Here is again 3.5 on the first shaft. Then second check that in between 4 and 5. That's why 4.5. 4.5 and last is a 6. 6 is there. Okay. Means you will get the 3, 4, 7, 8 and 6. 14 is there. Then see again we want to check that here is a which is the less value. Which is the less value? First one is the less value. But we want to check again IG stage. We want to check again IG stage. How to check the IG stage? Or which is the IG stage? Where we get the maximum gap? Here is a 2 is there. 2 2 is there. Okay, this is nothing but the IG stage. Okay, remember that. How to calculate the IG stage? Here is a, if you have considered this node, then gap is a 4 is there. 1, 2, 3, 4. Okay, then what is the value of 5 raised to 4? 5 raised to 4. Check that. You will get the IG stage is nothing but the I max divided by I minimum. Okay, then you have to check that what is the I max value 5 raised to 2 and 1 divided by 5 raised to 2. You will get the 5 raised to 4. What is the value of 5 raised to 4? You will, if you have calculated 1.78 raised to 4, then you will get the 10. 10 is less than, we require the value less than 8. Less than or equal to 8. But this condition is not satisfied. Not satisfied. Okay. Then for this second IG stage, what is the IG stage? Again check that. For this, here is a 3 is there. From the center again 1.5. You will get the 1.5, 5 raised to 1.5, and here is a 1 divided by 5 raised to 1.5. You will get the 5 raised to 3 is there. 5 raised to 3 is there. If the 5 raised to 3 is there, then you will get the 5.62. This is less than 8. This condition is satisfied. Which condition is satisfied? Second one. That's why here you will get the summation of node is less, but they are held in the IG stage. Okay, that's why you will get the feasible solution is second one. Second one is the feasible solution. Okay, guys, remember that in the some books you have given 3, 1, 2, 3 is the feasible solution. In the books you have given, we are getting the number of structural formulae are 8 formulae. They have drawn the 8 structure diagram. Then after that they have find out the IG stage value. No need to do this. Okay, you have to use your conditions, that 4 conditions, and check which value, which formula you will give the feasible solution. That formula, for that formula you have to draw the structure diagram. Suppose you will get the 4 feasible solution, and also IG stage also feasible. Okay, suppose here you will, they have given the 4.56 less than 8. This condition also satisfied. Then after that you have to go to the node method. Okay, if the IG stage and all these 3 conditions are satisfied, okay, and you will get the number of structural formulae are 4. Okay, feasible solution. Then you will get here 1, 2, 3, 4. Then also you have to use the node method. Here write the node on the first shaft, second shaft, third shaft, and check the which is the minimum value. This answer will be correct. Okay, all of you getting how to use the node method. Next lecture we will complete the remaining part. Today we will stop here. Thank you.